Hello, everyone. Boy, you guys are in a hurry. Hi, everyone. Oh, I left my laptop. Hold on a second. Okay, sorry about that. Okay. How is everyone this evening? Okay. There are some names I don't see here. Couple say just user. A couple, I don't know who they are because, well, JJ, I don't know what that is. So if you could just put your names in the chat so I know who's here. Hi, Kyle. I don't know who Crazy Girl is. Who's Crazy Girl? Seth went to the moon? Okay, I didn't get to have dinner yet, so no talking about food. Welcome back, Avery. Nora, you always lock in. Who's Crazy Girl? Did I miss it? Hey, Brooke. All right. Okay, so let's do this. Okay, and Brooke, you're not gonna fail. Shh, you're not gonna fail. We're not gonna fail. We're gonna go in with positive vibes. We're gonna do this. I'm telling you. All right, folks. So we're gonna go over some test questions. Hey, Kennedy. Is that Kennedy? Yeah. Okay. Oh no, that's Kendall. Sorry. I think I need to move my screen back a little bit. Oh, Chance came over to visit. Hi, Chance. That's Chance, everybody. Oh, wait, nope, wrong way. Everything's backwards on my screen. He's over here. No, I had it right the first time. He's over here. Okay. Oh Lord. Let's hope he decides to go do something else tonight. So, okay. So let's go ahead and look at some questions. So we went over the Unit D checkpoint, right? So let's go over Unit E. I kind of had it open. Oh God, I can't do Tori again. Okay. Oh God, you. Oh. Hey Jessica. Which Lily? I got like 3 of them. Oh, hey Lily. Where is she? You're not gonna fail. Hey Matthew. You're not gonna fail. We're gonna do this. We're gonna do this. We got this. I promise we got this. She can't chat. Well, tell her I said hello. Well, she can hear me, right? Okay. So we have a graph. Okay. I don't think you can see my screen. Oh, the bright light on the screen. Okay. So you see my computer screen? All right. You see my computer screen? You should see 4 pictures here. Okay. Of the 4 pictures, which one shows which one does not represent an object with a constant speed? Okay. Where you going? The whole point of this was to prepare for the test, Brooke. You can't run as soon as we start doing work. So which one? Maybe I should try to do a black background, see if that helps. I don't know if I can do dark mode on this. So is hers. I don't know why it dark moded earlier. It doesn't want to dark mode now. Okay. Who's Nani? All right. Anyone got the answer? Hi, Mila. Hi, Diana. So anyone got the answer? All right. I got to tilt the screen a certain way. Which one of these 4 represents something not moving at a constant speed? The curved one. Very good. Thank you. Okay. Yes, you can bring bracelet kits for the friendship bracelets. The curved one. Okay, so all of the straight lines, whether it's the one that goes like this, the one that goes like this, or the one that goes like this, all of those represent lines that are a constant speed, but the one that curves, that represents something that is not a constant speed. Good. Okay, so Katya is doing an experiment involving mass and gravity. She places 1 kilogram of marbles, 1 kilogram of paper, and 1 kilogram of foam rubber in 3 identically sized and shaped containers. She plans to drop each container from a 10-meter height and measure the time it takes for each to fall. What do you predict will be the result of Katya's experiment? So the marbles will fall the fastest. All of them will fall at the same speed. The marble and the paper containers will fall faster than the foam, or the container with the paper will fall the fastest because paper can be heavy. So which one do you think will fall the fastest? They'll all fall the same, exactly. Very good. Okay. So Kara designed an experiment to test the effect of forces on motion using a spring scale and different masses. Okay. She pulled a mass of 10 grams across the table with a force of 10 newtons. She repeated the experiment with a mass of 20 grams and 30 grams. How can she improve her experiment? She can test one mass multiple times. She can increase the number of masses she tests. She can increase the number of times she tests each mass. And she can change the force she uses each time she tests the mass. Oh, Zoe's here. Yay. Hi, Zoe. It's not B. It is C. Increase the number of times she tests each mass. So she's got 3 masses she's testing, 10, 20, and 30 grams. But if she tests each mass multiple times, then she can make sure that she's getting consistent results for each mass that she's testing. And she's looking at how forces on motion using a spring. She's looking to test the effect of forces on motion. So each mass impacts force. So as you increase the mass, you increase the force. So she is testing that. Hi, Lily. Hello. Oh, I'm seeing a lot of faces today, or a lot of names. I said I was going to sign all the yearbooks after you take your test. I am going to sign the yearbooks. I promise. I promise. Who's HWA Cosmics? Hi, Mary. I promise every class who takes their test, when they finish their test, I will sign your books. Okay. All right. So drawing a pendulum. Okay. So this, I'm going to see if I can show you the pendulum. Okay. So you see that pendulum? That picture shows up pretty clearly. So they want to know in this pendulum, where does potential energy convert to kinetic? Okay. So yes, we'll make friendship bracelets. I'm going to have friendship bracelets all the way up to my elbow. Okay. So this is A, this is B, and this is C. Okay? So they want to know where does potential convert to kinetic? Okay? So your choices are A to B and B to C, A to B and C to B, B to A and B to C, from A to C and C to A. Now I know it's not A to B and B to C. Correct. A to B and C to B. But it's easier to show you. Take a look. From potential to kinetic goes from here to here and from here to here. Okay? Oh, okay. So I think it's easier to show you on the screen because I know you can't really see the question. So that's why I thought it would be better just to show you on the screen. Okay? Even Lewis? Okay. So, all right. What do you mean not Lewis? Lewis was a good sport and wore the hat when we did the energy unit, and he put on the feminine hygiene product hat. Remember that? It was kind of terrible. I still have the picture of that. All right. So Padma is riding a bike down a hill, and she gets to ride. Oh, and as she gets to the bottom, she applies the brake to stop the bike forward motion. Which of the following statements best describes an example of friction acting on the bike? Yeah, he doesn't do his work all the time, I know. The ground pushing up on the bike, Padma's hands squeezing the handle of the brake, Padma's body pressing down on the seat of the bike, or the surface of the brake rubbing the rim of the tire. He had more than just a diaper. D, correct. That is correct. The surface. D. Good. You guys are doing pretty well. Forces are applied to the boxes as shown in the diagram. Which statement incorrectly describes the forces acting on the boxes? Okay, so we're going to have to show you the boxes. So we've got 3 boxes, okay? This one has 50 newtons and 100 newtons, 50 and 100. This one is 25 newtons on one side, and this one is 75 and 75, okay? So this is A, this is B, and this is C. Now, the second one is unbalanced, so is the first one, okay? So the first one and the second one are unbalanced, the third one is balanced. You with me? So which statement incorrectly describes the forces on the boxes? The forces acting on box 3 are balanced because the net force is 0. The forces acting on box 3 are balanced because it does not change speed or direction. Yes, you are smart. The forces acting on box 1 and 2 are balanced because the boxes change speed because of the applied forces. The forces acting on box 1 and 2 are unbalanced because the net force acting on box 1 is 50 newtons towards the left, and the net force acting on box 2 is 25 newtons towards the right. C. It is C. It says the forces acting on box 1 and 2 are balanced. That's a lot, Avery. That's a lot. The hat part, the diapers on the head part, that's a lot. So the problem with this question, and this is one that you have to read very carefully, it literally says the forces acting on box 1 and 2 are balanced. Hey, Letty, I did not see you pop in. Welcome. All right. So next question. Margot wants to test 2 cars of different masses to see which one hits the wall with more force. To find out, should she crash both cars into the wall at the same speed or different speeds? Same speed because speed is a dependent variable. Same speed because mass is the independent variable. Different speed because speed is the independent variable. Or different speed because force is the dependent variable. You want to see the dog? They want to see the dog. What? They're asking to see the dog. He's currently playing at the moment. They need to be seeing the numbers. My husband said you need to be seeing them numbers. When he's done playing, I'll call him over. Right now, he's currently in the middle of a tug of war with my husband. I don't know if you can hear him growling at the moment, but he's in the middle of a tug of war. It's his rope. You hear that? So, yeah, when they're done doing all that, Shelby's still here. Shelby is hanging out. She's in her space at the moment. Well, apparently I taught an older brother who knew about Shelby. I'm being chastised for doing very little review. We have a tortoise. Yes. I'll bring her out in a little while. Okay, so Should she crash both cars into the wall at the same speed or different speed? So she's trying to figure out two cars of different masses. Yeah, I'm not doing a house tour. Oh, he's a junior now? Oh, yeah. I did have your brother. Okay. Well, it's two different masses, so it would be the same speed because the mass is the independent variable. That is correct. So the answer actually would be B, because speed, the mass is the independent variable. The mass is what you changed. Okay, you're not measuring the speed. What you're measuring is the force at which it's hitting the wall. No, he wasn't. He was pretty quiet. I didn't have a dance party. You're making up rumors, Avery. I did not have a dance party. Okay. All right. Question number 8. Law of universal gravitation. It states that both masses and distance of objects affect the gravitational force between them. Gravitational force increases as the mass of the objects increase. Gravitational force decreases as distances between the objects decrease. Okay? Which of these statements is considered a scientific law and not a scientific theory? So, these statements explain what will happen under certain conditions. These statements involve claims made by an individual without evidence. These statements tell what happens under certain conditions in the natural world. These statements are well supported and widely accepted explanations of nature. The answer is C. Good one, Matthew. Good one, Kendall. Good one, Mila. The answer is C. Yes. Hey, Justin. I did not see you sneak in. Yes, C. Okay. Yes, I am proud of you. The answer is C. These statements tell what happens under certain conditions in the natural world. So, the thing to know about laws versus theories. Theories will seek to explain. They will have a ton of evidence. They will have people who tested them over and over and over. They will have multiple hypotheses. Yes, you're smart. They will have multiple hypotheses, okay? A law simply states, it just says it. What goes up must come down. It just says it. It doesn't seek to explain. It says, in nature, this happens. There's no explanation for it. It just is. Okay? Does that make sense? A theory is going to seek to explain. It's going to seek to give you hypotheses that have been tested and proven, or tested and substantiated. Hi, Lily. Which Lily is that? I've got like 3. Oh, you got in. You're able to chat now. Cool. Jojo, see what? Hi. Now, who's this? Who's Jojo? Oh, okay. You told me who you were a little while ago. Yeah, y'all are stressing me out. Now you gotta make me go back through the chat. It's like 3,000 people who are telling me their name. Oh, Lord. Come on. Why are you doing this to me? All right. Why are you doing this to me? Have we already had this much of a chat? Oh, Diana. I remember. I didn't even have to go back and look. Who's Lame Jackal? Oh, hey, Joey. I didn't even have to go back. As soon as I thought about it, I was like, wait a minute. I remember it's Diana. Okay. So here's another question. A contact force. Oh, wait, did I skip a question? No. A contact force is a force that is exerted by an object when it touches another object. Which of the following is an example of a contact force? Hair standing up after rubbing a balloon, two magnets repelling one another, an apple falling hard to the ground in an orchard, a car braking and tires sliding on an icy road. Which one is an example of a contact force? D, that is correct. Vikram tosses a ball in the air. The ball's motion is shown below. Okay, let's see if I can show you the picture. All right, you see the guy threw a ball and whee. Okay, we see the picture. Someone's going to join my live. Okay, more the merrier. All right. Oh, that's okay. They can join. They're testing tomorrow. They can join. All right. Oh, you see the dog? Knox. Oh, there he goes. Okay. So, which of the following is most likely the reason the ball changes direction and begins to fall to the ground? I'll bring them back. Let's finish the question and then I'll bring them back. The ball gains mass as it rose in the air. The force was no longer being exerted on the ball. The force of gravity causes the ball to change direction. The force exerted by the air on the ball increased as the height of the ball increased. KNOX. Three, the force of gravity caused the ball to change direction. Knox. They're asking to see him. I promised I would bring him. What do you mean not right now? I can make him come. They asked to see Knox, come here. He came all the way over here, looked at me, and then ran away. I'm reviewing. They just, I think they're done. Okay. Next question. He'll be out here momentarily harassing me. Triple beam balances and spring scales are devices used to measure height and weight. All right, here are pictures of triple beam balances and spring scales. Okay, so this is a triple beam balance, and that is a spring scale. Okay, I should not have clicked on that picture like that. Okay. Yes, I remember the Blickets. No, not triple T. Hi, Sue. So, which statement best describes the relationship between mass and weight of an object on Earth? If the mass of an object doubles, the weight of an object is halved. If the mass of an object doubles, the weight of an object doubles. If the mass of an object doubles, the weight of an object quadruples. If the mass of an object doubles, the weight of an object is halved. No, I haven't done this question yet. This is 11 on end of unit E. Not C. The relationship between mass and object on mass and weight of an object on Earth. It is B. If the mass of an object doubles, the weight of an object doubles. Okay. That's hilarious. Okay. Charlotte is investigating Newton's second law of motion. She hypothesizes if she applies a constant force of 10 newtons, then increases the mass of the toy car, she will result in an increased acceleration. Based on Charlotte's experimental data above, how could she phrase her conclusion? Okay, so in order to answer this question, of course, I'm proud of you. Hey, Brooke. Welcome back, Brooke. When did you do these? I mean, you took a test on this, but I haven't gone over these yet. Okay, so you would need to see the table, which is kind of hard to see. If you look at the table, you would need to see the data, which is kind of small. So that's kind of the data there. Force applied 10 newtons, mass of the toy car. So as you can see, as the mass of the toy car increases, the acceleration of the toy car decreases with the same force applied. Okay? So, were you guys able to see that? All right, I'm trying to shrink it back down a little bit so I could actually read it. Were you guys able to see that? I just did. He went back in the bedroom. I'll go get Shelby in a minute. I got to finish these questions and then I'll go get Shelby. Okay, so based on Charlotte's experimental data, how should she phrase her conclusion? So she said that if she applied a constant force of 10 newtons, the increase in mass would result in an increase in acceleration. Did an increase in mass result in an increase or decrease in acceleration? I don't think I can play the electromagnetic spectrum song while I have the live going. Oh dear. Okay. It resulted in a decrease in acceleration. I'm not on my phone, I'm on my computer. Yeah, we just heard thunder here, so it might trigger my dog. It results in a decrease in acceleration, correct. Good. All right, so we got 3 more questions in this section and then we're done. An engineer's model of car bags, an engineer made a model of car airbags to help him think about how it works. He made sure that some characteristics of the car were accurately represented, but he did not include all of the car's safety features in his model. Is it acceptable that he ignored some of the characteristics of this model? No, because he ignored some of the car's characteristics, and a model should be like the object he represents in every way. Yes, but only if he represented the characteristics that affected whether the model looks like the car, because the model should look like the things they represent. Yes, because only if he represented the characteristics that people would be interested in knowing about, because they're only used to communicate with information with others. Yes, but only if it represents the characteristics that affect how airbags work, because models need to include characteristics that are relevant to what is being studied. Knox, you're like right there. Oh, you made it back to the kitchen? Come here. There he is. The answer is D, correct. Yeah, that's my doggy. That's one of them. The other one, he just went into the bedroom. He's my little old man. All right, 14. The National Transportation Safety Board used data on vehicle fatalities to determine the safety ratings of cars for consumers. Now, this is another data table here. That's kind of terrifying that your dog is a skinwalker. I don't know if I want to meet this dog. So, using the data, which vehicle would most likely issue the highest safety rating for its occupants? Okay, so in this case, I'm going to have to just kind of talk you through this one. In car 1, the total occupant fatalities was 7.1. Fatalities of other vehicles was 2.7, and the total fatalities was 9.8. Car 2 had an occupant fatality of 2.8. Fatality in other vehicles was 2.5. Total fatalities was 5.3. Car 3 had an occupant fatality of 1.3. Fatality in other vehicles of 4.3, with a total fatality of 5.6. So the thing that this question tells you, which vehicle would the NTSB most likely issue for the highest safety rating for its own occupants? I'll miss you guys too. I really will. Well, if you're thinking about your own occupants, even though the total fatalities is slightly higher for car 3, its personal occupants had the lowest fatalities of 1.3, so it would be car 3. So the answer would have been, in this case, D. It had the lowest number of occupant fatalities, and car 2 and car 3 had very close total fatalities of 5.3 to 5.6. Is it pouring? This is Elizabeth's mom, and I'm getting all of these right. Yay. That's hilarious. That's awesome. Oh, that's great. Rana is goalie for her soccer team. Her coach has been working with her on how to deflect a shot for the goal. The coach used a picture to show her the angle at which most shots approach a goalie. If Raha was the girl in the picture deflecting the shot, what is the element that Raha could control so the ball is deflected away from the goal? The mass of the ball, the speed of the shot moving toward her, the direction of the ball coming toward her, the direction of the force applied blocking the shot. Okay, where are my soccer players? That's the picture. I'm proud of you too. That is awesome. The answer is D. That was a resounding D. Yes. The force applied to blocking the shot. That is absolutely correct. Yes, it's absolutely correct. The force applied. You can't control the mass of the ball, although isn't the mass of the ball supposed to be standard anyway? But you're not the one controlling the mass of the ball. Um, you can't control the speed of the shot coming towards you. That's typically the person who's kicking the ball. The direction the ball is coming from, again, that's the person kicking the ball. But you can control the force with which you hit the ball to block the shot, right? Okay, so that was the last question for that test. How are we feeling so far? Anyone have any questions? Listen. Oh, good. How are we feeling about Unit F? Do you need me to go over some of the Unit F stuff? Oh, thank you. Well, genetics, you're not gonna have to worry about for this test. Don't feel kerfuffled. I'm still tickled over that word. Do not feel kerfuffled. I'm trying to see if I can find Unit F in here. Oh, it would help if I actually had F chosen. You don't need a periodic table. You're not getting anything on chemistry. Oh, you want to see Shelby? Okay. Oh, I'm not connected to the network. Hold on. I can't open it because I'm not connected to a network. All right. And I'm going to need to connect to my Wi-Fi. All right, I'll do that in a minute. Let me go get Shelby. Variables? Well, we've been talking about, but what do you need? What question do you have on variables? This is just this semester. Oh, sorry. Sorry about that. That's kind of funny. All right, let me go get Shelby. Let me go get paper to put under her. She likes to pee on people. All right, I'll be right back. Okay, she's a little mad at me. Stop it, Shelby. Stop it. She's a little mad at me. Okay. All right, Missy. Stop. Yeah, she's got a little bit bigger. Knox, leave her alone. Come on. She's already not happy to be out of her spot. All right, come on. Girl, come on. Where are you going? Yeah, she said hello. It's a her, and no, you can't have her. Yeah, she's a Russian tortoise. Oh, what? Will you look? Okay, see, she. If you laid down, you'd be okay. Don't cry during the test. You're gonna be just fine. You're gonna be just fine. Oh, uh, she was $40. I paid a lot more than $40 for her. All right, pretty girl. We're gonna put you back because you are annoyed. All right. Okay. Okay. She's annoyed. I have to bring her whole habitat. I can't just bring her. She needs her habitat. So, oh, okay. Yeah. Nope. Nope. Girl, see, I knew you were going to do that. She's peeing. I'm putting her back. Be right back. Okay. Okay. All right. Did he come back? All right. So did Mr. Knox come back while oh no, this isn't Knox, this is Chance. Knox is right here. Knox, come here, boo boo. Come here. Come here. This is Knox. Don't sit on Chance. Okay. See, now they're both sitting here. See? These are my boys. Okay. So, does anybody want help with any of the questions from the last test you took? I'm willing to do that. What is a dependent variable? A dependent variable. Okay. No worries, Lily. A dependent variable is a variable that is changed by, it's the result. Okay. It's the result of the test. So it's no, it's not. Well, it's not, it's the test variable. So, for example, if I am trying to test fertilizer and I want to see how much it helps the plant grow, the amount of growth is the dependent variable. Who's a cutie with the blue shirt? Okay, let me see. Okay, now I can open the test if we need it. Okay, and the independent variable is the variable that you control, you change. Oh, me. Oh, oh I'm sorry, I wasn't paying attention. Aw, don't make me blush. Okay, all right, so, oh, for the love. These seriously, I'm in my computer. Why are they being so difficult? I just want to access this file. They're being very difficult. Sorry, guys. I'm trying to access the file so we can go over this test. It's not letting me open it. I mean, we used it. I don't understand why it's not letting me open it. I think it's because I'm at home. I try, guys. It's not letting me in that test. Not from here. So I can't access it. I'm sorry. Do you have anything you want me to go over? Any questions that you have? Okay, now we're talking about some weirdness. Let's not go crazy. Wavelengths? Okay. So wavelength versus frequencies. All right, so wavelengths and frequencies. Wavelengths are the y'all really want me to play the godforsaken electromagnetic spectrum song? You guys are trying to make me insane. All right. Well, wavelengths and frequencies. The longer the wavelength, the shorter the frequency. The shorter the wavelength, the longer the frequency. Or the higher the frequency. Okay. So, in other words, radio waves, for example, have long wavelengths. Since they have long wavelengths, they have very short frequencies. Okay. Very few waves pass a given point in a certain amount of time. Knox, what are you doing? Okay. But when you have very short wavelengths like gamma rays that are like this, you have a lot of waves that pass a point in a very short period of time. Does that make sense? You're listening to the song right now? You guys know I can give you gamma's not a sound, no. Gamma is an electromagnetic wave. I'm not sure what's going on with my dog right now. He's pushing me out of the way. Okay. So you do need to know radio waves have the longest wavelength, gamma rays have the shortest. And you do need to know red is the longest wavelength, violet is the shortest. So radio waves, microwaves, infrared, red, orange, yellow, green, blue, indigo, violet, ultraviolet, X-rays, gamma rays. Does that make sense? Good night, Mila. Are you leaving us? Good night, Mila. It was wonderful seeing you. No, X-rays in between. You have ultraviolet, then X-ray, then gamma ray. Well, I'm not going to be on too much longer. I haven't had dinner yet. I'll be heading out soon. I don't know if they give a reference sheet, but usually if they don't give a reference sheet, any formulas you need are on the test. I can tell you it is, and I'll put it in the chat, electromagnetic spectrum song. That is who made it. Bye, Mila. I'll see you tomorrow. Get some rest. Electromagnetic Spectrum song by Emerson Fu. I'm not gonna have time to play it tonight. I've actually got to eat soon. Mila's in my third period. Do we have any last minute questions? Today's a little bit of comfort food. We're gonna have chicken sandwiches and tater tots. You're not gonna cry. There's no need to cry. I think you'll be fine. Just your way ground. I can't reopen the way ground. Kingdom, phylum, class, order, family, genus, species. Please don't flip a coin for the answers. Oh, Lord. Now y'all are starting to stress me out. I need to sleep tonight. Not sleeping is very bad for my health. You don't need solvent and solution. That's not going to be on your test. Wait, I'm sorry. Did I miss something? Extra credit for what? Yeah, it's anything that was in the first semester is not on your test. You don't have to worry about the periodic table. Oh, the boot camp. Yes, the boot camp that I'm supposed to do the extra credit for the boot camp, but I accidentally left my sheet in Miss Peacock's room. So I asked her for it today. I just need to get the sheet from her. Density, mass, and volume was last semester. No. It's on energy, forces in motion, and waves. Yeah, I meant to answer you, but I didn't see Miss Peacock's response till after school, and then I had ELP. So I don't know. I don't know. Yeah, none of that stuff is on. It's just energy. I think, don't have a heart attack. I think it's 65 questions, which is good because it means the questions are worth less. Kids typically do better on the final than the classroom tests. About 65, from what I was told. Um, I get the scores right away. You get 100 minutes. Welcome back, Diana. Yeah, we get 100 minutes. I get the scores right away. They're scored immediately. Um, I won't know. I probably won't know what the scale is right away. So I won't tell you. I won't necessarily tell you what your scores are right away, because if I'm not told what the scale is, then I won't tell you what the scores are. Well, there's a scale, but I may not know what the scale is tomorrow, because usually the scale doesn't come out until 50% of the district tests. So that may not be until Tuesday of next week. You are very, very welcome. It was my pleasure. So once the scale, no, you'll be fine. Trust me. Once the scale comes out, you'll be fine. Trust me. Okay. So I just don't want people panicking. Okay. Usually my students do pretty well. I just need you to focus and think and don't rush through the test. All right. All right, guys. It is time for us to get out of here. I need you guys to get some rest. You are very, very welcome. How bad is it out there? Oh, it is bad out there. No dance party. You don't want to see me dance. Oh, well, you guys saw me dance at the dance. So I cannot play the electromagnetic spectrum song here. But if you guys are good and you work hard on the test, I will play the electromagnetic spectrum song in class one more time. Okay? I am not going to dab. I do remember dancing with you, Justin. No, I am not going to immortalize that on the internet. I'll see you guys tomorrow. I don't even know what the sprinkler is. Come on now, I'm old. I do remember you playing the leapfrog. Okay, let's not age me. Okay, I'm gonna go now. Bye, everyone. I hope you have a wonderful night. Get some rest. Please get some rest, especially those of you testing tomorrow. And I will see you tomorrow. Have a wonderful night's sleep. Bye, everyone. Take care. Good night. Bye, Kyle. I will sign your yearbook. I promise. Bye. Oh, well, thank you. You're welcome. See you tomorrow.